Hey everyone, I'm Mark Goldstein. I work at Chime. I lead the Client Foundations team, and we're going to be talking about how we made our mobile infrastructure agent ready. Before we go into that, speaking of mobile infrastructure, I have a question. I'm wondering, by raise of hands in this room, have you ever waited when doing mobile development, let's say for a build? Anybody waited? Okay. Does anyone enjoy that process from raise of hands? Okay. And generally, what's your go-to thing? Do you go to the bathroom? Do you stand up? Do you change your sit-stand desk? Scroll on Twitter? Would you say it's relatively productive or unproductive things? Hands up for productive. Okay, I see maybe 4%. Cool. So I'm just curious before we go into it. So we're going to be talking about mobile infrastructure, agent ready, also human ready. And we're going to be covering a few things. There'll be time at the end of questions. But yeah. So why am I talking about this? Is the clicker working? I don't think the clicker's working. No. Okay. So why are we talking about this? So something happened. I don't know if all of you have experienced this, but AI has accelerated our workflow. At Chime, we recently announced how it's impacted us. So in the past 4 months, AI-assisted development has gone from 29% to 84%. The number of PRs for our mobile app has gone up quite a bit, 14% year over year, and generally builds are way up. And we've also got Software Factory that we're working on. We talked about in our last quarterly earnings, our committees kind of shipping alongside engineers. And so all these things have happened. I'm sure lots of things have happened in the industry and places that you've worked. At Chime, it's definitely something that we've been embracing. But one thing that's kind of shown up is our infrastructure isn't really keeping up. I mean, traditionally, like everyone was saying, you wait for builds. They're slow, You're making changes, depending what they are. Sometimes they could take 10 minutes plus, depending how optimized your plugins are, your distributions, where you're hosting it, where you're building your machines. If you're an i5, it's going to take quite a while. It's also, distribution is painful, right? Test flight, reviewed sometimes really quickly, sometimes it takes a while. Play Store tracks, lots of constraints out of your control. And testing your app is pretty annoying. This QR codes, download links, switching versions, going in between. I'm sure that's something that we've all felt. Meanwhile, if you look at the React Native world, we looked at the actual changes that require a new build for our app, and it turns out it's about 5%. But machines, and I'm going to refer to machines instead of engineers, because yeah, there's AI. You might have your own machine, but maybe you have work trees, so you're working on your machine many flows. Maybe you have Cursor Cloud Agent or your own Software Factory, right? But in the world where only 5% of changes actually need a new build, 100% of changes rebuilt anyways. And maybe that was okay if your team was 5 engineers, right? And you had changes and 5 engineers had to wait 10 minutes, a couple times a day or a couple times a week. But let's see how that scales, right? Let's say you have 50 machines and you have 3 native changes a week. That kind of starts to add up. That's 25 hours a week. That's 325 hours a quarter, right? If you just kind of take a full-time engineer's full bandwidth, that's over 3 full-time engineers focus, full-time. And there's also all those things we were talking about. There's context switching. You go up. I don't know if you've ever had this experience where you go do a thing. Okay, it's a building. Let me go do this thing. Grab a cup of water, and then you come back. And I was like, oh, build failed. It's not available. It can be really costly. Or you start some other task, then it succeeds, and you completely forgot where to pick back up on this previous task. Scrolling Twitter. And now if we scale that up with AI, so with what we've experienced, now that goes up quite dramatically, right? To 450 hours a quarter, that's like 4 or 5 engineers. And now what we're seeing with cloud agents, work trees, typical developer, depending on the industry, but is working on up to 4 build streams at a time. Let's say you're checking out your own code, you're reviewing a PR you want to validate, you have a cloud agent, and some bug that you're looking into. That's really big and very different in the way that we're used to working. And so we kind of have to do something about this. This is not a sustainable pace and pain point. So the way that we approach this is in 2 layers. So in the React Native world, I'm going to oversimplify here, but generally there's the native layer and the JavaScript layer. So the native layer where your native modules are, core architecture. If you can't go from new architecture or old architecture without rebuilding the app, as far as I know. Tell me if I'm wrong. Config, those sorts of things. And so in our app, that's 5% of the time. The JS layers, generally, that's like our higher level of abstraction in React Native where you write JavaScript code, and that's a level of abstraction where it's natively rendering things for your app. And so the way we're going to approach this is on the native layer, twofold, for both development and for dog fooding, right? And then for the JavaScript layer, we're going to ship our bundles, right? Probably these 2 things are probably things you're familiar with, and we're going to go into it a little bit. So from a high level, generally for debug builds, we are going to carry to cache. Pretty simple solution to this problem. But really quickly how this works, you build an app, we have a local cache. If you're building from one branch and then you switch branches and you go back, you shouldn't have to rebuild. Simple. But if you are checking out your friend's code or your coworker's code, there's a remote cache. It already exists. Download and launch it. In the case that there isn't a build, and let's say you're actually developing the new feature, okay, maybe you need to build the app. Maybe the PR wasn't opened by an agent, and you actually, in your computer, regardless, it's going to be committed to the cache. Under the hood, we're using a custom config with Expo fingerprint. That's worked really well for the development. And these are debug builds. Now with this alone, this produces, it's a really simple fix, but produces more of a line that maybe was looking exponential to looking something a lot better. Maybe on the order of magnitude, I think it's 13 times less on each of these things. So now even the worst case scenario, somebody who's, YOLO, shipping everything, 10 work trees, 10 agents, everything, it just doesn't scale that badly. You're not wasting a lot of time. You're able to get quick feedback just from changing native changes. And then this is really just infrastructure that helps AI-enabled velocity, right? If you go up, you kind of, you see the lines, they're pretty far apart. Cool, so debug builds aren't enough, right? That's for development, right? And then we're gonna get into how this ties into AI a little bit after this, but debug builds aren't enough. You need to validate your changes also like on your actual app. So we also want to have a cache for non-debug builds. So we ship release-like builds without test flight, without Play Store test channels, and again, it's pretty simple. You commit, you have a fingerprint check. If it's there, we skip it. If it's not there, we build and upload it, and we also start to associate it with a channel and with over-there updates, which we'll get into there. And then it's downloadable in our dog feeding app. It's called Chime Dog Emoji. And yeah, every native fingerprint auto triggers a build. So developers no longer have to write, okay, let me trigger a build. I made a change. I have to re-trigger a build. That was frequently has happened to me and many other folks. It's just that cognitive load of an engineer, of somebody who's triggering an AI agent. It's gone. And so that's really 5% of the story, right? The other 95% is JavaScript, and we don't even need a build for that. So what are we going to do there? Again, the space in React Native is super developed. There's over-there updates, there's EAS, there's Expo updates. And so we're using a really simple, kind of similar pattern using our own self-hosted and then the fantastic Expo updates package. So similarly to the full native ones, you commit, CI publishes an update on your channel. By default, if it's a PR, it'll just be your branch. It posts it to S3, and then your device is able to access that. And then if we put it all together, we are shipping these experiences seamlessly for all the dog fooders. So why should you have the cognitive load of switching between the two? So let's say you're in the app or you're outside of the app. We are checking for an update. So first thing you do is you see, does this fingerprint match the fingerprint of the update? And so just to give you a high-level view of what a fingerprint is basically a representation, like a unique representation of your platform, so iOS or Android's build of the app. So if we have an update for a channel, let's say we're on feature 123, and you made a change to the native app icon and splash screen, then when you push your code up, it's going to have a fingerprint that differs from the previous commit. It's going to trigger a new build, and then if you go in the app, your fingerprint is not going to match the next one. So what it's going to do is sideload the app via the release-like build from the cache, and we'll go over a demo of that. If it does match, which is most of the cases, again, like 95% of PRs, 98% of product-related PRs, it's just going to over-there update it, and it'll be downloaded. Under the hood, we're using Apple Enterprise to power this, just basic S3 and AWS utilities and APK overrides. So what's next, right? So we ship this, and like, why? Where does this tie in? We're all using AI, we're using agents, and where this is going to next is to enable our software factories. So the flow will go from prompt to agent to worker and then to human validation. So I'll walk through it quickly. So first, you have somebody in our factory. It's like, okay, I want to add a copy button to transaction, right? We have our software factory goes and makes the changes and decides if this change requires actual device validation, and then spins up a worker, a Mac, or a Linux KVM. Then we have the simulators that spin up. Here's where the first part of our infrastructure kicks in, the build cache. Without this, the more you would use cloud agents, the more you would have to like actually spin up and build the app. But in this case, with the build cache, what we'll have is basically machines that are warm with all of the last builds. So you can just optimistically keep on loading in all of the last builds into your machine, so that if you have somebody working on a change, it's already there. You can get really quick startup time and start validating the changes. From there, validate the intent. So a lot of times agents, we're talking about like bug bot, and a lot of times agents have like a self-bias. When you read a paper and it's like, oh, this looks great, and then you hand it to somebody else and like none of this really makes sense. You kind of generally, it's helpful to have like an adversarial agent, not just review its own work that it created, but another one. And so at that point, we're able to validate the intent and behavior within the agentic loop, and then also with that pass complete, send screenshots and videos along to the user. And here's where the other part of the loop comes in, is the dog fooding validation. The over-there update is already available, the build is already available in the dog fooding app, and the software factory, our committees, is able to push to the user, hey, here, check out the changes, here's a video and a screenshot, you can iterate over there, or you can check it out in the dog fooding app immediately. Without this loop would be possible, but it would be incredibly painful. Imagine what it would look like having to manually go download the build, find it, and switch to the change, all those sorts of things. So I'm going to demo this. I have to exit this because I had to use preview. OK, so let's do the JS one. So this is our app. You can see if we go to the camera here from a pull request, you can check out the changes directly. So this is just one way to access a change. Let's say you open up a PR and you scan the QR code. It's just going to deep link you to the app, and you will see the metadata over here. So the installed build, where you're on, the version, the runtime fingerprints, and the target builds. In this case, I used cursor to just change the primary colors to be purple yam. And you can see we can just download this update. This isn't over there update. I wish I could hide these play controls, but so we're going to download the update, and what this is going to do is get the JS bundle and replace it for our app. Then when we go into our dev tools and we find a primary button, we'll see that it's now purple yam. You can also see that we're no longer on that channel. We can go back to the main channel, which is what most folks by default test on. And you can also see that you're up to date. Next, we can see that the button is purple yam color when I press this next button over here. And so it's applied, and then we can also just go and browse different channels and switch back to the main channel, which will show that it'll revert that change. If we move on to the full binary one, so let's say it's not as simple, it's not a JS update, and it requires a full binary update. So for this one, you'll see it's the same experience, but it's going to actually have to download the whole build. So we're on main, there's a new update available, and this time, you need a new app build required. So what we're going to do is we're going to side load it from S3. We're going to get a pre-signed URL that's short-lived, that has the manifest plist that's going to allow you to install the app. So I just did this here. The internet, it seems like it takes a little bit longer over here, but you can see it's doing a full reinstall of the app. And then when I go ahead and reopen the app, I'm just going to skip to that for time. You'll see that it is fully up to date. But first, one thing that we're not doing, we're going to do, we went to the new native app build, but what about the latest over-there update? So if in that case that hasn't been already applied, we apply it. In the future, we're probably going to swap the latest binaries with the latest OTA. That just requires a couple changes with signing. If you have more questions about that, feel free to ask me. So you can see we're up to date. Going back to the presentation, let's talk about some of the impacts. So the impact is really clear. I mean, in general, making dog fooding easier, we've been able to get active chimers on an internal build from 7% to over 62%. So previously, a lot of people who were dog fooding really have strong dog fooding culture, but it's really hard to get people to test an early version of the build if it's already, unless you have an easy way to access it. So beforehand, we had a strong presence of folks testing the app, but it was after the release was cut, but before the release went out. Now we're able to get folks testing the app as soon as someone merges into main. Another clear impact that we had was around the pre-release bugs from 2% to 50%. Similarly, that impact is related to the fact that now folks are testing the app before it's cut. So we're able to find something and apply a fix really quickly. We also found many Sev0, Sev1 incidents that have been avoided due to this that would have otherwise required hot fixes or recutting the app. And generally, just being able to make a change and get it on your app that you already have in 90 seconds has had a huge impact. People on the team really like it. There are so many things like that a lot of the things, and we'll get to this point, that you don't hear are your biggest opportunities. And so until you introduce something, and some of this takes time and behavior change is really hard, but once you get it in people's hands, the impact is really clear. Incredible feature, saving lots of time. I can't test on the simulator. It's really powerful, saves time, and the numbers speak for themselves too. And this isn't like an innovation. I mean, watching this, like, okay, you use a cache, you're using it for the updates, but my point is this is operational hygiene. And I kind of want to ask the question and encourage you to think about this, is that what skeletons are you hiding in your tech debt closet? Because I have a feeling if you take stock, there might be some where the cost is really high. And if you just take a few minutes to crunch some numbers, you might have a really easy, interesting, high-value project you can get a lot of buy-in and a lot of impact for. And I think that the main takeaway around this is the inefficiencies that you tolerated are going to become the bottlenecks that AI multiplies. And if you kind of don't take stock of these things, it will show up. And I hope that you take a look at it and you found this useful. And I am open for questions. I just want to give some kudos, huge kudos to Camille K, who's right there, who really carried so much of the build cache work. The whole team at Chime and Raf, who helped me with these slides. He's got a talk tomorrow afternoon you don't want to miss. So yeah, any questions? I have some time, so if anyone has questions, I'm all ears.